Okay, we are starting lesson 78. This is the last lesson in this unit. So the do now says John starts a new job making $20,000 and receives a pay raise each year of 2%. John wants to find out how much money in total he will earn for the first 3 years he is at this job. Calculate John's total earnings. So the key word is total earnings. So we see it's a percent increase. So we might be thinking an exponential growth formula. But if we use that, that just tells us how much he's made in the third year. We want to know his total earnings all 3 years. So instead of me sitting there and finding out how much he makes year 1, year 2, year 3, and then adding it up, we can use that formula that we talked about in the last lesson, which is down here, for the sum of a geometric series, which this is because it's growing by this constant percent. We're multiplying by this r. So we can see that the first term is how much he earned in the first year. The r, remember, r in terms of the geometric series is not like r the percent, it's what do we multiply by to get the next term. So the percent is 2%. So the rate as a decimal is 0.02, right? But what are we multiplying this by to get to the next term? We're multiplying by 1 plus 0.02. So 1.02 for the r. And then n is how many years or how many terms. So that's going to be 3. So if I plug that into my formula, I have 20,000 times or minus 20,000 times r, which is 1.02 to the third power, all over 1 minus r. So 1 minus 1.02. Okay, and we talked about how you need to be careful putting that into the calculator, making sure you use your fancy fraction, and we get $61,208. Okay. So a couple things with this formula. Sometimes you might see it written this way. Sometimes you might see it written this way. It's the same thing. It's just whether the a sub 1 is distributed into this parentheses or not. It's really just, two ways to write the same thing. All right, so we are going to use this formula to answer some questions similar to the do now, similar to some of the ones that we did in lesson 77, but some of them a little bit more complex. Okay, so often these are going to ask you to write a formula as well. So Alexa earns $33,000 in her first year of her career and earns a 4% increase in each successive year. Write a geometric series formula S sub n for Alexa's total earnings over n years. Use this formula to find Alexa's total earnings for her first 15 years of her career to the nearest cent. All right, so another thing to be careful of is what are they asking you? There's actually 2 questions here. So write a formula and then use the formula. So when you write a formula, you should have the variable in it, right? So sometimes people skip over this step. They write a formula, but they plug n in to be whatever they need it to be and never say what the formula is. All right, so as soon as I see geometric series formula, I know I'm going to use this. Okay, so I need S sub n equals, I need the first term. So a sub 1 is 33,000. So 33,000 minus 33,000 times the r. So if it's a 4% increase, that as a decimal is 0.04, but I'm multiplying by 1 plus 0.04 to get to the next term. So that's going to be 1.04. And I want the formula for n years. So I'm leaving n as is. And then 1 minus r on the bottom. So this is my formula, right? N is in there. So that means I can use that for any formula or any n that is possible. Okay, so then they say, use this formula to find Alexa's total earnings for the first 15 years of her career. So now we're going to plug in 15. So you want to have them separate. So now I'm going to say, okay, N is 15. I'm going to plug it into the formula. Times 1.04 to the 15th power over 1 minus 1.04. And I'm going to plug that in, and I'm going to round to the nearest cent. So I get $660,778.39. Okay. All right. So now we get into some of the mortgage questions that we saw previously. I forget what lesson number it was, but they gave you this crazy looking formula, which again, you're not gonna have to memorize these formulas. They're gonna give you the formulas, but you just really have to read carefully of what they are saying about the formula, what everything represents, and what exactly they're asking you to find. Okay. So it says Jim is looking to buy a vacation home for $172,600 near his favorite southern beach. Can you guys see this? Sorry. The formula to compute a mortgage payment, M, is M equals P times R times 1 plus R to the N over 1 plus R to the N minus 1, where P is the principal amount of the loan, R is the monthly interest rate, N is the number of monthly payments, and Jim's bank offers a monthly interest rate of 0.305% for a 15-year mortgage. With no down payment, determine Jim's mortgage payment rounded to the nearest dollar. Okay, so a couple things going on. So we need to talk about with no down payment. So we talked about this in that previous lesson. I think it was at the end of the last unit. I'm not sure. I'll look it up and link it. So with no down payment. So remember, down payment means the money that you have, the cash that you have to put towards the house. So if he doesn't have a down payment, that means he has no cash of his own to put towards this house. So if the house costs this much and he doesn't have any money, then his mortgage is going to have to be for this entire amount. If he had a down payment, if he had like $20,000, then he could give them $20,000 and then only need $152,600 for a mortgage, right? So with no down payment, if that was different, then this amount, principal amount, would be different. Okay, so P is going to be the amount of the house. That depends on the down payment. Okay, then there's the R. Now be careful here. So R is the monthly interest rate, but remember when we write the R in the formula for exponential growth and decay, we always have to take that percent and divide it by 100. Like we can't put 0.305%. We have to write what percent means. Percent means divide by 100, per 100. So even though this is already a decimal, and we might say, oh, it's already in decimal form, it's not, because it's still percent. So I still have to take that 0.305 and divide it by 100. So the R is actually 0.00305. And how do I know that? Because it has the percent symbol. If it has the percent symbol, I have to divide by 100. If it didn't have the percent symbol, that means that they're giving me the R already as the decimal. Okay, which sometimes they do, which is confusing, yes. So you have to pay attention. And then you might be saying, well, I thought you just said it was 1 plus R. Well, look at the formula. They already took care of that in this particular formula. This formula is different than the other formula. Similar, but different. So, they already kind of took care of that in here. Okay, so now I need the N, which is, remember, the monthly payments. So if it's monthly for 15 years, I'm going to have to multiply 15 times 12. And that's going to give me 180 payments. Okay, so again, reading carefully here. And then I'm just going to plug it into the formula. So M equals P, which is the principal. How much did they need the loan for? Times the R, so times 0.00305, times 1 plus R, so 1 plus 0.00305 to the 180th power, divided by 1 plus 0.00305 to the 180th minus 1. Okay, so now the hardest part here is going to be able to type this into the calculator correctly. Okay, so I'll show you a screenshot of exactly how to type it in. But again, if you use the fancy fraction, it literally looks like this. That's why you need to use that. If you don't, then you're going to have a lot of parentheses that you're going to have to put in place, or a lot of separate entries that you're going to have to put. Okay, so after you put that into the calculator, they want it to the nearest dollar. So that's going to be $1,247. Okay. All right, so now it says algebraically determine and state the down payment rounded to the nearest dollar that Jim needs to make in order for his mortgage payment to be $1,100. So now let's say he looks at this and he's like, oh, that's a little too much. I can't, handle $1,247 every month. So I'm going to need to lower my monthly payment. Well, in order to lower your monthly payment, that means you have to have a lower principal. And to get a lower principal, that's what I was talking about before, you need to come up with a down payment. So you need to somehow come up with some cash to put down so that your principal is lower, so that your monthly payment will be lower. So they want to know, well, how much cash does he need? What's his down payment? His down payment's not in the formula, right? It doesn't have a spot for down payment. What it has a spot for is the principal. So really what we need to do is find the principal needed. And then once we know the principal needed, then we can just subtract and figure out, all right, what's the difference and how much cash does he need to come up with? So that's really what we're going to be finding. We're going to be looking for the new principal, okay? That doesn't change how much the house costs. It still costs that much. We just have to come up with some of our own cash. All right, so Jim needs, Jim needs to make an order for his mortgage payment to be $1,100. So we want M to be $1,100. And everything else is going to stay the same. So M is going to be $1,100. I'm going to put that over here. I'm following the same formula up here. Okay, so M is $1,100 equals P is the new principal. So I don't know how much he needs to have yet. Times the rate is the same, 0.00305. Times, I'm just following the formula, 1 plus 0.00305, still for 15 years, so still to the 180, I almost wrote 15, divided by, the bottom is 1 plus the rate, so 1 plus 0.00305 to the 180th power minus 1, okay? So really what I'm doing is I am solving for P. Now, luckily, it's P times this whole mess, right? So I need to get rid of this mess and get P by itself. So that's easy enough, right? So if it's connected by multiplication, then I would just divide by this whole crazy mess. So you might want to put this whole crazy mess into the calculator first, get that decimal, and then just divide that. Now you don't want to round too much, because if you round too much here, you're going to be off by a lot, okay? Now you might have it already in the calculator from up here, so you can copy and paste it so you don't have to sit there and retype it. Okay, so if you put this part into the calculator, you get something like 0.00722765558. Okay, don't round that. The more you round, the more off you're going to be. And then you're going to divide by that. And you're just going to copy and paste it from the calculator. So you're not retyping it. Oops. Because you could type it wrong, like I just almost wrote it wrong. Okay, so I'm dividing both sides by that. I'm just going to write that because I'm going to just keep it in my calculator. Okay, and then P is equal to whatever that is. And that happens to be $152,193.19. Now that's the principal. Remember, the principal is the amount of the loan. So this is what the bank will give you. But the house still costs $172,600. So you need to come up with the difference. So $172,600 minus $152,193.19. And they did say to round to the nearest dollar. So they want $20,407 down payment. Okay. So he needs to somehow come up with 20 grand. Okay. Let's look at example 3. So it says Jasmine decides to put $100 in a savings account each month. The account pays 3% annual interest compounded monthly. How much money will Jasmine have after 1 year? So even though they don't say the word total, that's what they mean. They want the total amount. So we have to be careful here because there's 2 formats of the way that these choices are written. So like choice 1 and 3 is written like a times b to the x, right? So that would be like for choice 1, 100 would be the initial amount. And then the b would be 1 plus the rate as a decimal, 1 plus 0.03, raised to the 12th because it's 12 months, right? But if we think about what that means, that doesn't take into account that it's compounded monthly, right? That would be compounded annually. And then even if, the time is in months, it's not taking into consideration the fact that it's compounding monthly. And that's going to give you how much she has in the 12th month. It's not giving you the total. So even over here, they have a different B, which we'll talk about where that comes from. It's not giving you the total. It's giving you what she has in that 12th month. So when we want to know how much money she will have after a year, that we want that total all together, that's giving me the clue that I'm going to have to use that series formula because that will add everything up. So then let's look at the parts of these two. So they have the 100, they have the 12. The only difference is the R that you're multiplying by to get from month to month to month. Is it 1.0025 or is it 1.03? Okay, so our first clue, even if we had to just guess at this, 3% compounded monthly, we know that that is not just 1.03. Now it does have the 12th power here. However, think about when we had our lessons when we were actually in school. We were talking about how do we transform that B value when it's yearly to become monthly. Right? So we're talking about a year, but we want it written in months to represent what we're multiplying by to get to the next month amount, right? So if we had 1.03 as our B, that's for 1 year. So if we needed to talk about it in terms of months, we would want 1/12, raise that to the 1/12th power, and then raise it to the 12th. Remember we did that? That was, oh God, I don't even remember the lesson. I'm not going to remember the lesson number. But it was back when we were in school in the exponential functions unit. Okay, so if it's 1 year, that's 1.03 to the 1. But if we want to change that to how much it's going to need to multiply by to get it to be monthly, we raise it to the 1/12. However, that is raised to the 12th, right? Because this is going to be now in terms of months to get to 1 year. So what is this? 1.03 to the 1/12. If I type that into the calculator, that's approximately 1.0025. So that's why choice 2 needs to be our answer for this question. Okay, if it didn't say compounded monthly, then I wouldn't have to worry about transforming that 1.03. All right, so a little bit trickier of a question, especially because they put the two different structures here. But if you typed these in, hopefully you would realize when I type this in and when I type this in, it's not that much money, not much over $100. So hopefully you would think, wait a minute, that doesn't make sense after a year. If she's putting $100 in each month, she's not going to just have $103. So also look at the structure of the expressions to see which one you think makes the most sense. Okay. All right, so example 4 and 5, I'm just going to kind of go through how you would start, and then I want you to try to do those on your own. All right, so it says a ball is dropped from a height of 32 feet. It bounces, can you guys see that? Just to make sure. It bounces and rebounds 80% of the height from which it was falling. What is the total downward distance in feet the ball traveled up to the 12th bounce? So think about what that means. You're starting at 32 feet. That's the initial amount, right? Then it bounces and rebounds 80% of the height from which it was falling. So it falls 32 feet, then it rebounds to 80% of that. So multiply that by 0.8, and you get the next height of like 25.6-ish, right? Then it's 80% of that. So you're multiplying by 0.8 each time to get to the next term until you get to the 12th one. And then you're adding them up. Well, that's a geometric series. So instead of me finding all 12 and adding them up, I can use the formula S sub 12, and I have A sub 1 is 32. I have R is 0.8. It's not 1.8 because I'm not adding 80%. It's not bouncing higher, right? Think about if you bounce a ball and then you don't touch it. The height it comes up is less and less and less and less until it just finally lands on the ground, right? That's what this is talking about. So it's multiplying by 0.8 because it's getting shorter. And then the N is going to be 12. Okay, so see if you can plug all that stuff in and find the correct choice. All right. And then the last example here, again, I'm going to kind of go through it, and then I want you to see if you could try it. So Jake wants to buy a car and hopes to save at least $5,000 for a down payment. The table below shows the amount, summarizes the amount of money he plans to save each week. So in week 1, he's going to save $2. In week 2, he's going to save $5. In week 3, he's going to save $12.50. And in week 4, he's going to save $31.25. So based on this plan, which expression should he use to determine how much he has saved in N weeks? Okay, so think about what kind of pattern we have here. Is there something that you are multiplying by to get from week to week to week? Okay, so if you can find the number that you're multiplying by, and you know the first week he's saving $2, then you can figure out R, and then N is just going to be left as N because that is going to be a formula. It's not a specific number of weeks. It's just however many weeks we want to use to figure out how much money he's going to have. Okay, so again, see if you can go through that and try that one on your own. Okay, so I'll post the answer key as well, go through the practice and the homework, and then post any questions underneath, and I will try to get to them. Have a good day.